How many of us actually went and did 4.4 and actually used these formulas? It's this. Yes, sure.
Oh, yeah, I did do it.
Okay. Because one of the things I said last class was, hey, write all of these formulas down, right? And do 4.4. And if you get stuck, try it, get it wrong, hit similar question, get it right, hit similar question, right, over and over, just so you do enough to kind of balance things out. Now, you also have 5 questions on the lab work that involve these questions as well, right? So today in class, I'm going to give you guys some problems and let you guys work on it and see how you guys do. Ready? Here we go. Oops, that's not going to do anything. All right, good luck. Go bananas. Try something. Do something.
Like, this is like the lab works, like question 6 on the lab work. I couldn't, and it's basically kind of like that one.
Perfect. If you can do this one, then you'll know how to do the lab work one, right? My whole thing is this. I need you guys to try. I need you guys to fail and learn from your failures. Well, since it's equal, we're solving for x. We got to find a value for x. Yes, you do. Try something. There's got to be something you know. You don't have extra tips? Oh. That's no good. Extra tips are useless at home. So now you know that you should always store extra tips. Again, make a mistake, we learn from it. What the no. Let me see. You can't go from here to here. Correct.
The thing is, I don't know the first step. I'm confused.
I think this step is wrong too.
This?
Mm-hmm. Try it. Try it. I need you to try. I need you to make mistakes. You can. It's just what you did after that is wrong. When you divided 3, it was wrong. That's what I'm saying to you. When you divided 3 is where it went wrong. Huh? Has to. But you can apply some rules. Do, 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 do. All those rules, which one to use? Which one to use?
I don't know where to start.
Make a decision, then make it right. So decide whatever you want to do, just start it. Ooh, I like it. You're so close. You're like right there. It's like you're right here. That's how close you are. Here. Yeah, you can't do that. No, because that's not a coefficient. You are. She got close, right? She's very close. You think your brain isn't functioning. Your brain is functioning just fine. Your issue is that you want to be right. Life is not perfect. Right? You're not going to get married to the first person you date. Very few. Very small percentage. Very small percentage. Am I right? Whenever you have kids, chances are you're going to drop them once. Chances are you're going to drop them once. Not physically drop them, but you might place them on the bed, turn around, they fell off. It happens. You're not going to be perfect. The only thing you can do is strive to be. The only thing you can do is make a mistake and saying, well, next time I put them on the bed, guess what? I want to make sure that there's no way of them rolling off the bed. But you got to make the mistake in order to learn. From now on, she's going to bring extra tips for her pen. Because she made a mistake, she's learning from it. I'm only asking you guys to make mistakes. Because right now, holy cow, what is this? She's alive! All right. She's going to teach us how to do this problem. Good luck with that, too. None of that is right. My hands covering is wrong. So, yep. The power rule goes right here. Then you do the product rule. All right. You guys ready? I'll show you several ways of doing this. So don't erase yours because you think it's wrong, because it's not. I'll do it your way first, all right? Which is not the way she did it. Doesn't mean you're wrong. I think yours is the easier way. Okay, so one of you guys wanted to do this. So here, let me do it this way. I won't put it in red. So what they decided to do was they saw multiple logs, so they want to move it all to the same side. Great. So we got 3 log base 2 of x minus 1 plus log base 2 of 4 is equal to 5. What they wanted to do was the product rule on the left side, but the problem is that we have a 3 as a coefficient, which means we actually have to apply the power rule. So the power rule is going to be log base 2 of x minus 1 to the 3rd power plus log base 2 of 4 equals to 5. Now he can use the product rule. Does that make sense? From here, because we only have 1 log, we can convert this to exponent form. It just happened that way. Do you understand what the heck I just did? What's the opposite operation of cube? Cube root. So I took the cube root of this side. What's the cube root of 8? Okie doke. Again, you did it a different way, so it's okay. Sometimes it's necessary. Because like you said, you didn't know where to start. Right? So most people don't know where to start, so they're like, hey, I see a bunch of logs, let's put them together. Let's group them together on one side. And then use the product of the quotient rule and the power rule, right? So that's what they did. Okay, great. No big deal. That's fine too. All right? So what's another way? Well, another way is this. What they noticed was this. They noticed that this base is a 2. And they can write 4 as a base of 2 as well. So I'll make this way blue. So what they did was saying this is 2 squared. Agreed? So that means this is going to end up being just 2. Because since the bases are the same, these are opposite operations. So therefore, this 2 is what's left. Understood? So where do we go from here? I got to divide by 3, right? I got to get the log by itself. So what do I do from here? I can do 2 things from here. One is that I can convert this to exponent form. Or I can use the opposite operation of log base 2. Yes?
If you convert it to the exponent form, it would just be 2 to the first equals x minus 1. That's how I learned how to convert.
Oh, that's fine. Again, this is not about, it's about how we think.
So how would you solve it? Like instead of what she just said.
I probably would have solved it this way. Because when we convert this from log form to exponent form, the base wants to go to the other side, and then the log goes away.
We can just solve, the log.
What do you mean?
The last one of we can just solve. No?
To be just 2? It is. Yeah. Yeah. That's why I want to see yours.
It's the same. It's the same. I know.
Oh, it's equal to 2. Yeah.
We can solve.
Yeah. But usually people can't see that. You know what I'm saying? Like people don't know that log base 2 of 8 is 3. They need to see why it's 3. You know what I'm saying? All right, so here's the thing, guys. As a sidebar, from here, I said that there's two ways of solving this, right? One is this right here. The other way, and I know that it seems like I'm giving you guys so much, but it all depends on how our brain thinks, because the opposite operation is very important as well. So log base 2, what's the opposite operation of log base 2? Oops. Using 2 as the base, yes. And with that being said, you would have x minus 1 equals 2 to the first, which is the same exact thing, right? But this, we're converting it to exponent form. This, we're using opposite operations. As long as the bases are the same, they cancel each other out, so I'm left with just that. This is 2 raised to that power, that side as well, okay? So we're still getting to the same thing of x equals 3. Anybody else have a different way of thinking about this? Nada? I thought you'd never ask. There you go. You guys must be busy at the marina. Gesundheit. For another month, maybe.
After Easter. We're on finals.
I'm sure you're going home and saying, I better watch Chan's videos.
No, I have.
Better watch his lectures.
I don't even think he needs to. He hasn't even been to the gym.
Nope, he hasn't.
We don't leave the marina until maybe 6:30, 7.
But you guys are making buku bucks. And you guys are just hoping that taxing on tips would just go away. That'd be so nice for you guys.
Well, we get cash too, which is nice.
The cash part is easy, yeah. It's the credit card ones. They have to report. But once that tax goes away, whoo, you guys are going to be making
Could you
bank.
make the bases the same or no? Like, you know what we did here?
Mm-hmm.
Here or no?
Only if ln is by itself.
Could you divide by 5?
Sure. Why not? Isn't it 5 times ln? Okay. Like I said, just do. Let the mistake lie where they are.
So when I divide by, does the ln disappear?
Say it again.
Would the ln disappear or?
When you divide by 5?
Yeah. Just get ln by itself.
How did you get this equation from this? That part you can't get. You're like, let's turn the page and let's not let him see that. Guys, do something. Doesn't matter if it's right or wrong. Just do something.
I was trying to do like what you did and like move the 5 to over here. That doesn't look right, does it?
No.
No.
No. You're just moving random things in the random places. Mm-hmm. Nope. Guys, can I ask you guys this problem? If I have you guys do this problem, Or if I ask you guys to do how would you do this problem? Huh? Okay, first you would divide by 5. And then what would you do? Huh? I'm not talking about this. I'm not talking about this unit. I'm talking about if you were doing this right now, if it was an immediate algebra student came to you and going, how do you do this problem? I'm really confused. Why? So you would take squared on both sides because the squared and the square root are opposite operations of each other. And how about down here? You would take the cube root on both sides because the cube root is the opposite operation of cubed. That makes sense to me. Guys, these two problems are not any different. They're exactly the same. Exactly the same. Except you can't square ln and make the ln go away. You can't cube root the ln to make the ln go away. You just need the opposite operation of ln. So yes, this right here, you would divide by 5. And what's the opposite operation of ln? An L. Very, very, very not close. What's the opposite operation of ln? I gave you a whole list of opposite operations. And the last class, and the last class, and the last class, and the last class. See, I gave this sheet right here. Guys, everything here is all about opposite operations. Here, let me zoom in here. This one right here is saying that if the bases are the same, they cancel each other out. That's why P is equal to P. If the bases are the same, they cancel each other out. That's why P is equal to P. Got it? I wonder what's the opposite operation of ln? What's the opposite operation of ln so that P is equal to P? E. What's the opposite operation of just log? Base 10. Okay or not? Okay, let me ask you this. How would I use this and convert it to exponent form? Let's convert that to exponent form. I want to see how you guys do with exponent form. How do we convert that to exponent form? Is it base of e? Yes. Here, let me help you guys out as that was just mentioned. She just said, isn't this just a log base e? It is. Maybe that will help you guys get to exponent form. And when you watch the live lectures. Oh, absolutely. It should give you the same thing.
Yeah, that makes sense.
Are we understanding? Or are we just freaking out more? Ready for the next problem? There you go. There's a lot of different ways of doing this one. Many, many. Yes, you can. Just do it. Just do. Confidence doesn't come being successful the first time. Just do. Just do. You think we have an answer? It is the right answer. It's interesting how you got there. It is.
Oh, I got it right? I don't know how I did that for real.
Do I divide the 4?
These are
No, you can't, because it has a power to it.
So I had to write that down. So you want to get x by itself, correct?
Right?
Y squared.
That's a 4.
No, okay.
That's a 4 squared. Because that's 16, right?
So that
So how do you make it up top so the bases are the same? So 1/16 is 4 to what power?
Oh, am I supposed to answer that?
You were, yeah. Was I supposed to answer that? Mm-hmm. 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 Because that would be equal to each other and then still get the same answer. That's why I was like, interesting how you did it that way, but all right, sure, you know. Well, the problem is that when we did those problems, sometimes it's not the same base, right? We can't get it to the same base. How many ways would you guys like me to show you how to do this? So number one, if you remember, when I taught this lesson, the first example, we were able to get the bases the same. Remember that? Well, the question is, can we get the bases the same? So yes, we can get the bases the same. Because 16 is 4 squared. I can't have it in the denominator, so I got to pull up top, kicking and screaming. So it's 4 to the negative 2. So if you guys type in 4 to the negative 2 in your calculator, you'll get 1/16. Since the bases are the same, the power must be the same. That's one way of doing it. It is. That's why it's like, just do. Because it all depends on how your brain thinks. Now, how about this? How about we convert this to log form? Unless you're telling my breast stinks. So what if we converted this to log form? What would it be in log form? How do I convert this whole thing to a log form? This is exponent form. I want to convert it to log form. Is that right? The base goes over to the other side. Log base 4 of 1/16. The reason I'm bringing this up is because this is very popular with people who want to keep on thinking exponent form to log form to exponent form, right? So this becomes really popular. Now people can hear me at home. Okay, so what do I do from here? What's happening on the right side? Starts with quo. Oh, wow, you guys are good. Is that true? What's log base 4 of 1? Anybody? What's log base 4 of 1? This is the reason why we have the point 1, 0. Log base anything of 1 is 0. ln of 1 is 0. Log of 1 is also 0. Anything of 1 is equal to 0. Remember, in these notes, we said this. Right? The reason why we had this critical point right? Doesn't matter what the base is. If we take the log of it, it's equal to 0. Yes. So if we had no clue, 0 clue how to make the the base the same. We don't see it. That 4 and 16 can't get to the same base. Right? Then what would I do? Well, we use common log or natural log. Agreed? Okay. Which we'll do later on, but this would do the same thing. Any questions here? No questions. So we're ready to do another problem. Okay. I can think of 3 different ways. I can think of 3 different ways of doing this.
Do these two, they don't cancel out?
They cannot.
Okay.
They'll only cancel if you get it to be the same base. Mm-hmm. Do something. Do something. Doesn't matter. Do something. Yes. Or just write down do something.
Yeah, I'm okay.
It's not stupid. It's close. It really is very close. You're close. You did something, but and the thing of it is that what you started to do is not wrong. It's absolutely right, but then you kind of stopped doing what you needed to do because there was a rule in there.
No.
The ln is in the wrong place.
For this one? Or for both?
Yeah. How did ln end up in the power?
Would the element cancel out?
No. But what rule do you have over there? We just did that rule too in our problems.
Wait, did it have to do with what you were saying that the ln is like the opposite?
You could do that. You could do that. Remember, ln, you got to take the ln of something. Ln just doesn't mean anything just by itself. It just means that you can't spell lin or lens or length. So, ready for the different ways? One way is this. Get in the same base. Another way. Mm-mm. You forgot the quotient rule. And ln of 1 is 0. Huh? And ln of e is 1. You did? Those are the 6 rules that I just showed you.
Like right here, yeah.
Oh,
1. Okay, yeah.
oh, there's a bunch of... It all depends on how you think. I'm not trying to make you think a certain way. This, again, you guys are experiencing free will. It is all about the rules that you have to remember. If the bases are the same, that means the powers must be the same. Just like if I said to you, 2 to the x equals 2 to the 5th, what's x equal to? What happened to the 2? Because it doesn't really matter, right? Because the bases are the same, so the power must be the same. Okay. Can we convert this to log form? If we convert it to log form, isn't it going to be x plus 2 equals log base e of 1 divided by e, which is also the quotient rule? Wait a minute, that looks familiar. It looks like these. Look at that. Oh my goodness. We have a same. Any other questions? Was it too easy? Just a cake. I don't know. The review isn't out yet. Tuesday. The week after. If you look on campus, you will see. If you were watching my videos, then that means you've opened Canvas. Which on the very end, it tells you what date is the exam. All right, how about this? Good luck. Just so you guys know, you can't get the bases the same. Don't even try. 7 raised to the 3.268. No, not really. So if you want to have an example to follow, even though my exam isn't going to have any examples to follow, you might want to check out the second example we did in last class notes. In case you don't know what I'm talking about, it would be this one right here. When we asked the question, hey, what if we can't get the bases the same? Then I said, oh, we would use common log or natural log. And I told you that I like to use natural log because it won't interfere with my fractions. So if you guys want to go back to that example to help, go for it. Oh, you're going to try that, huh? You want to try that? Yeah, okay. Good luck with that. Now, here's the thing. Right there, if it was asking for approximate and you wanted decimal, you could do it that way. But it's not going to ask for decimal. It's probably going to ask for exact value. So doing that will not work. Question is, can you get this answer as well? Can you get that answer as well? Because that might not be a choice, but that is a choice. Or that might be a choice, and that's not a choice. So you got to make sure you got to be able to do both. Make sense?
Am I going in the right direction?
Sure, sounds good. Where do we go from here? Where do we go? Where do we go? Where do we go? This week, 13. As I said 2 days ago. Look at how pretty that writing is. It looks so good.
Was that set up wrong?
Nope, that's right so far. Is what do you do next? That's the part that matters. What do you do next? What rule is sitting right in front of you that you should do? Sure. As long as the answer is exact. Okay, so far so good. You guys might want to put parentheses around your binomials, though. As I said, the same thing.
No.
That's fine. But what's our next rule here? Uh-huh. With a power?
I don't even know if I'm starting it right.
You're starting right. But I said you might want to put parentheses around your binomials. Well, hopefully there's more than just a 2. Huh? That could be an answer. But what is another answer? So right here, guys, so here's where the dilemma is going to come into play. The dilemma is going to be, where do I go from here? Right? If you guys followed my work of what I did in the notes, this is what I would have done. Is that right? What you did was right. It was just different looking answer, but it's still the right answer. So I would do that way. That's the way I would have done it. And you would want to do it this way if there was x on both sides. So if you went back to last class's examples, that very last example had x on both sides. So you definitely want to distribute and get all the x's on one side. Now, what's another way of doing it? The other way of doing it is to divide the ln of 7 and then subtract the 2. Both of these answers are correct. Question is, are you able to get both answers? Because here's the issue. Remember, on your exam, it's multiple choice, right? So on the multiple choice, chances are this is going to be there and this is not, or this is going to be there and this is not. So let's say you get this, and you're like, Chan, there's no answer. But there is, because it's that. Or vice versa. No, you can just do the one way. Question is, do you know how to go from here to here? And do you know how to go from here to here? This is, what do you mean? This is what free will is about. It's not two ways of solving it. It's one way of solving it, two different answers. They're both right. They're both right. My concern for you is, on the multiple choice, You get that, but that is a choice. Do you know that that's the right answer as well? Over here, can I make 2 a fraction? Put a 2 over 1. I'll be subtracting fractions, right? What do I need in order to add or subtract fractions? Common denominator. So the denominator 1 is missing an ln of 7, so you got to multiply top and bottom by ln of 7. So I can convert this to this just fine. Over here, I can split up the ln of 7. If I split up the ln of 7, guess what? The ln of 7 would cancel out here, leaving me with just a 2. So I can make one look like the other. Do we understand that? That's why I'm showing you both of these. Do you need me to show you? Or are we good? We're okay? That's why on the lab work, I don't really care because I know they're both right answers. But the problem is that on the multiple choice exam, you're going to see one of those answers, but not both. And we need to know that one is right and the other one is also right. Questions? None? None at all. We're good to rock and roll. We're so excited. I'm hoping that you guys would do enough problems in 4.4 and the lab work so that until you don't have a problem, you don't need the sheet anymore. Because here's the thing that I was just telling the last class. If one of these problems, let's say, take you 4 minutes. If we have 25 problems, 4 times 25 is 100 minutes. Guess how long class is? 80 minutes. Class is only 80 minutes. So you have about 3 minutes per problem. So you want to do enough of these problems that these problems aren't going to take you 3 minutes. Does that make sense? This is why today I didn't teach anything. We just did problems. I ran out of problems already. These problems all came from your e-textbook. Yes, if you go in the 4.4 homework, as you go through the problems, hit similar question, similar question, similar question, similar question, similar question. Okay? If you go to Axis Pearson on the left side of your column, if you hit Axis Pearson, you'll go into MLM. And then when you get to MLM on the left side, you will see e-text content. If you click on that, go to 4.4, you can get directly into the e-textbook and just flip the pages until the end of that chapter, and there will be like 100 more problems there. Okay?
Isn't there like similar question too?
You can do similar question, but the problem is that it would just be similar, right? So if you remember how you did the last one, you're going to know how to do this one, right? Where at least the problems on the back of the book, you're going to have 100 different problems that you can go and do. Okay? And you can always, you're going to know what the right answer is because if you use ChatGPT, you're going to be like, what's the right answer for number 72? And they're like, there's the answer, right? So you're going to know. Okay? I'm just trying to heed a warning. I'm hoping that you'll heed that warning and that you'll do something about it before the exam. We have the exam about a week and a half, is that right? Well, really 2 weeks, yeah. Yep, not this coming Thursday, but the next. So, Because when we have some final exam reviews and then,
What's the date for the fourth exam?
I don't know. Something like that. So ladies and gentlemen, please have a wonderful, blessed day. Please be safe. Love you guys. See you guys. Have a great, blessed weekend, that is. See you guys next week.